Greetings everyone. Today we'll embark on a journey to understand how hackers leverage VSCode extensions to spread malware on Windows and Mac machines. Let's begin. So while scrolling through Twitter, I stumbled upon this interesting tweet from Nicholas talking about persistence method through VSCode extension. Persistence basically means finding a way to stay inside someone's computer or network even after you've initially gained access. It's like leaving a secret door unlocked so you can come back in later whenever you want, even if the owner of the computer thinks they've kicked you out. So this actually made me curious. What if it is possible to gain an initial foothold or initial access through this attack vector? So then I continued digging and tried seeing if there are any blogs out there on Google by seeing, has an apt group leveraged this attack vector in the past to hack a company? And I ended up stumbling upon MD6's amazing detailed blog on this attack vector. Before we proceed on to creating our own malicious extension, we must install a few libraries that will assist us in its creation and its packaging. First, we'll start by installing npm using Homebrew. npm is like a huge library of ready-made code for JavaScript developers. It's a time saver, letting them quickly find and use pre-written code to add features to their projects without starting from scratch. Next, we'll proceed on to installing a few more libraries. First one being Yeoman, which will help us generate the VS Code extension. And after that, we'll install VSCE, which will help us package it. Next, we'll head over to Visual Studio Marketplace and create a publisher ID. Start by providing some random name and make sure the ID you're using is unique, and make sure to write it down somewhere since we'll be using it when creating the extension. This will basically help us publish our extension to the marketplace. Now let's proceed on to creating the extension. First thing we'll do is navigate to desktop, run your code. Make sure to select the type of extension as TypeScript. Other than that, you can name it whatever you want, even the identifier and description. And also make sure you're using npm as the package manager. After Yeoman finishes creating the extension files, we can proceed on to opening up Visual Studio Code and then dragging the extensions folder to begin editing it. We'll start by editing package.json file. We'll add our publisher ID in here. In my case, it's AppleSec. For you, it will be different. And then we'll add the activation event. In this case, it's an asterisk. Now you might ask, what does this mean? Let's proceed on to understand what activation events are in Visual Studio Code. So activation events in Visual Studio Code are like triggers that determine when an extension should start working. The asterisk event basically means that the extension will be activated whenever the editor starts up, regardless of what the user does. It's like turning on a light switch as soon as you enter a room. The extension is ready to go as soon as you open Visual Studio Code without waiting for any specific actions from you. Now let's edit the code for the extension. We'll basically be updating the code to execute the command whoami and redirect the output to a file named POC in the temp folder. The code execution is possible with help of child process module in Node. This basically enables us to access operating system functionalities, like for example executing commands in this case, which is whoami. Lastly, we just need to empty the readme.md file since it will raise alert if that's the default. For the last step, we will now use VSCE to package it up so we can upload our extension to the marketplace. Now we shall go back to the publisher page and upload our extension here so it can be uploaded to the marketplace. We will have to wait a while for Microsoft to review our extension. It takes around like 5 to 10 minutes for them to scan it and review it, and after that it gets approved. Let's head over to the marketplace for extensions, and when we look up our extension we can find it right here. Let's proceed on to testing our extension. First thing, we need to make sure that the POC file does not exist in the temp folder. After that, let's open up Visual Studio Code, head over to extensions and look up our extension. After installing it, we should see the message implant is executed. Going back to our terminal, we find the output of whoami command in the POC file. going back to MDSec blog, they mentioned 3 methods of the extension installation. First one being through the UI, which we explored previously. Second is a way of manual installation, which is unrealistic if you're trying to phish someone. And third one is pretty interesting, which is through URI handler. I simply tested out the VS Code URI, added hello there.test, and it seems to be prompting me to open the Visual Studio Code. I went to the blog further and they basically explain how this is working. So first comes the VS Code, which is the URI, and then we have hello there.test. Hello there is basically the publisher ID, and after that we got the extension name. In this case it's test. So for our extension it becomes applesec.enox. So let's quickly test this out. We'll first ensure that the POC file does not exist. Open up Chrome. So this is just a simple demo page I've created, which contains the hyperlink which we discussed previously, which is VS Code applesec.enox. And if I were to click this, it prompts us to open Visual Studio Code, and after opening it, it prompts us to install an extension, and once I install it, our extension gets executed and the POC file is now created in the temp folder. And that's it for today. Thank you for watching.